All right, Chapter 9, Problem 21. We have a 2,500 kilogram trailer is attached to a stationary truck at point B, in figure 9-61. Determine the normal force exerted by the road on the rear tires at A and the vertical force exerted on the trailer by the support B. Let's go back to our question. Okay, so I've drawn the free body diagram here, and let's just go through a couple things real quick, just to start off with. So the rear tires are going to feel a force from the ground, and that's what FA is going to be there. The trailer itself has a weight, like starting from this M equals 2,500 kilograms, and then with gravity, you're going to have a weight on the trailer, so that's what's in the middle. And then there's also a force on the trailer caused by the support in the truck. That's FB. So what we're going to want to do here is use Newton's second law to our advantage. It's important that the system is in equilibrium because this makes sure the second 2 points are true. The sum of the torques and the sum of the forces are both 0. And we also want to note that 2.5 meters is the distance between the rear tires and the center of mass of the trailer, and the center of mass of the trailer, the distance between the center of mass of the trailer and the support is 5.5 meters. So what do we want to do first? We can use either the sum of the torques equals 0 or the sum of the forces equals 0. I just decided to use the sum of the torques, and I chose my pivot to be around B. You could do A if you like, but it should work out to be the same both ways. So going the way that I did, if you sum the torques, then you're going to have mg times 5.5 meters minus fa times 8.0 meters. So where did these come from? Well, if we choose the pivot point around here, and we also note, I forgot to say here that I'm calling any counterclockwise torques to be positive and clockwise torques to be negative and counterclockwise to be positive. Then if I imagine the bar here falling, this free body diagram, the free bar diagram more like really, a torque is going to be created anytime there's a force acting at a distance, and we see that there's only 2 places because there's no distance between the pivot and itself. So there would essentially be no torque at that point. But there is going to be a torque generated by the weight and by the FA. So yeah, downwards is going to be positive and upwards is going to be negative. So the signs come from there, and then it's just algebra after that. So I just got that FA is about equal to 17,000 newtons. So you should look for the answer exactly 16,844, but about 17, depending on where you round it, you'll get something like 17,000. Something similar for the second part. Since we already summed the torques, since we already summed the torques, we can sum the forces now. So if we sum the forces, we can just see that FA and FB are the only 2 that are upwards, and MG is the only one downwards. And there's no X forces, so we can just sum all the Y forces, right? We can call these Y if we want, but that's the only forces in the problem anyway. Then you just add FB and FA, subtract MG, and do your algebra, and you should find that FB is about 7,700 newtons.